Moving right along, let's take a look at ionization energy. Now, when we talk about forming ions, we have two things that are going on. There are cations and there are anions. Ionization energy refers to forming cations. So this is how much energy it takes to pull electrons off of an atom. Okay, so the amount of energy required to remove the outermost electron from an isolated neutral atom in the gaseous state. Okay, so the key here is remove. There's a different property that looks at the energy associated with adding electrons in. Ionization energy is looking at the energy to take electrons off. Okay, so when I look at ionization energy, I get a general trend that as I go across the periodic table, my ionization energy is going to increase. As I go down the periodic table, my ionization energy is going to decrease. Okay, now what is going on though that I see a dip here? I see a dip here. Okay, well, what happens is it depends on the type of electron we're pulling off. So if I'm looking at period 2, I have my 2s and my 1, 2, 3, 2p. Okay, well, my first two elements in period 2, I'm going to have that. Now, my next element, I have that. And so the dip that I see right here is because now the electron I'm pulling off is that one right there. Okay, so I'm pulling off an unpaired 2p. All right, and then I'm going to go here, and now I'm going to get to my next dip because here's 1, 2, 3, and then my next dip is going to occur because now I'm pulling off that electron. All right, so we see these dips. So our general trend is it increases as we go across, but when I move from 2s to 2p, and when I move from all unpaired 2p to spin pairing, I see those little dips. Okay. So there you can see the dips a little bit more pronounced. And then again, my transition metals, they kind of have their own thing going on. All right, so there's my general trend. As I go across, we increase. As I go down, we decrease. Now, when we ionize, okay, we always pull off electrons individually. So sodium does that, okay? And so that's the first ionization energy. Now magnesium, we're going to do a magnesium, and then we would take that magnesium and do that. So each electron comes off individually. And so magnesium, we have a first ionization and a second ionization energy, and then we see this giant jump. Sodium, we have a first ionization energy before we see this giant jump. Okay, the giant jump here corresponds to going from pulling off a valence electron to a core electron. So this is a valence. This is core. So this is a valence electron, this is a valence electron, and this would be a core electron. So we always see a huge jump in ionization energy when we go between a valence electron and a core electron. So ionization energy is always going to increase as you pull off more electrons. All right, so always increases. As you more electrons. Okay, and then it takes a huge leap when an electron is removed from a new inner shell. Okay, and so in blue are the valence, and in red are the core or inner electrons. And so you can see with sodium, we have a large jump between ionization energy 1 and 2 because sodium only has one valence electron. Magnesium, we have a giant jump between ionization energy 2 and 3 because we have 2 valence electrons. Aluminum, we have a giant jump between 3 and 4 because we have 3 valence electrons. Okay, and so the exceptions are what I was mentioning when we see those little dips. And so it depends on the type of electron we're pulling off. So nitrogen, we have all 3 2p orbitals with a single electron in them. And then when I get to oxygen, now I've spin paired one of those 2p's. And so that oxygen electron is a little bit easier to pull off than one of the nitrogen electrons because we're pulling off something that's spin paired and leaving a single electron in each of the 3 2p orbitals versus taking an electron out of one of the 2p orbitals and leaving one of them blank. Okay? All right, so let's take a look here. So I'm in period 3, and I want to know which element in period 3 corresponds to these ionization energies. So when I look at these, where do we have the biggest jump? Where do we have a massive spike in ionization energy? Between what and what? Well, if you said our spike was between ionization energy 5 and 6, you were correct. All right, so between ionization energy 5 and 6, we have a giant jump. So these are our valence, and this is core. Okay, so our large jump is between ionization energies 5 and 6. So, therefore, we have 5 valence electrons. So which element in period 3 has 5 valence electrons? Well, take a look at your handy dandy periodic table, and when I look, sodium has 1, magnesium has 2, aluminum 3, silicon 4, phosphorus has 5. So my element is phosphorus. And my electron configuration is neon 3s2 3p3. 2 plus 3 gives me my 5 valence electrons. So those are our ionization energies.